How many of you want fan or shall I switch it off?
Switch it off. Sir, off.
Tell me, which fan is that? Which switch? Which switch?
Top left.
Top left.
Yes.
ये बता तो सही कौन?
Sir, off. Sir, I love you.
Cut.
Okay.
Okay.
Sir, off. Thank you.
Is
Sir, AC on.
this speed is low, right? Let me make it full.
Yeah.
So,
Every country.
remove your t-shirts. Remove your t-shirts.
Go on.
Remove your t-shirts. Huh? All right. So क्या चल रहा था अपना? पहले जो लास्ट बहुत लेक्चर्स में नहीं आया जरा हाथ ऊपर करो.
क्या?
लास्ट लेक्चर किसने अटेंड नहीं किया हाथ ऊपर करो. 1 2 और that's it. ठीक है. तो लास्ट लेक्चर में हमने किया क्या था? What did we do?
Light. No.
Magnetism.
Electric venom.
Magnetism में कहाँ तक कर लिया हमने?
Well,
Well, so that means magnetism is completed.
Yeah, we completed it. We have to start.
Okay, so we have to start a new chapter
Sound.
and the last chapter, right?
Yeah.
That's the only topic left.
Yeah.
Okay, fine. So let's begin sound. Those who attended last lecture, anybody has any doubt on that topic? Did we discuss assignments? Did we discuss that?
Yeah, we discussed some questions.
No, from. Okay, let me do some questions from volume. Did we do classwork?
We did some technique.
We did some technical question. Also we do something. Okay, let us do some questions, direct questions. Open page 142 of magnetism. Do you have volume? You didn't bring volume today.
volume.
You all should have volumes. Join somebody who has volume. Let's do the questions so that once it will be quickly revised, and you'll also know what kind of questions come in from this chapter. Okay. So everybody take turn. Take turn. The first question. Volume.
A magnetic field lying in the dash in a magnetic field structure that
Take a volume. Page 142. So what is the correct answer? MCQ. Review questions.
continuous curve.
Yes. Magnetism. Review questions. This is question number. This is MCQ. So this is a fill in the blanks. Yes. जायसवाल था ना?
सर मैंने किया गलती से.
ठीक है लेके जाओ. इसको भेज दो. So first answer is continuous curves. Okay. Next 142. Next question. Alternate between boys and girls. Okay. Your turn. Second question. Two ends of magnet are called poles. That's correct. B. Option B is correct. Poles. Okay. Third option. Is that your volume? Then how do you know where it's on? ठीक है चलो दूसरे के लिए काम करो. Third. In a uniform. Third. Whose turn? Yes.
In a uniform magnetic field lines are curved.
Uniform.
B parallel. Yes.
Parallel, equidistant, straight line. Okay, so option B. Third is option B. You can test yourself and remember this now. Fourth, Jaiswal. What's your first name?
Satvik.
Satvik. Fourth.
Earth's magnetic field is also known as geomagnetic field.
Yes.
B.
B. Option B. Fifth. Fifth. Yes.
The resultant or net magnetic field at the neutral points is 0.
Yes. Very good. So that's 0. न्यूट्रल पॉइंट पे मैग्नेटिक फील्ड क्या होता है? 0. अर्थ का मैग्नेटिक फील्ड और मैग्नेट का मैग्नेटिक फील्ड इक्वल एंड ऑपोजिट होता है, इसलिए दोनों क्या करता है? कैंसिल कर देता है. ठीक है. सो दैट इज 0. So that is B. Okay, so we are done with MCQ. Now direct question. Next.
Natural occurring magnet.
Yes. Lodestone is a natural occurring magnet, and what is it? It's an iron ore. What's the formula?
Fe.
Fe.
2O3. No.
Fe3O4.
Fe.
3O4.
Just check what it is.
Fe3O4.
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 Is that so?
Yes.
This is lodestone. What is the spelling of lodestone?
LODESTONE.
So it is LODESTONE. It's not LOAD. It's LOD. Lodestone. Okay. So load as in it leads into one direction. That's how lodestone. When it is suspended, it points towards geographic north. That's why it leads into a particular direction, which is Earth's geographic north. That's why it is called lodestone. Load, lead, load. Okay. Next.
What is the natural magnet? What are the limitations of the natural magnet?
So natural magnet we already saw. Natural magnet is lodestone. It's a naturally occurring magnet. Generally, it is a iron ore. Okay. Named lodestone. So what is its limitation? Where's your?
Irregular in shape.
It's irregular shape. Then
So it's not weak.
magnetic strength is
It's weak.
not adequate, weak. Okay, these are two. So it is irregular shape and weak magnetic strength, magnetic field strength. Write down these points in your, if volume is yours, you can write it down. So limitations you write down, at least 2 limitations you know. It is in odd shapes and it has weak magnetic field strength. Question number 4, who's done? Yes, come on board.
3.
3.
I want that.
Artificial.
So, what is artificial magnet?
PNC.
Why are the artificial magnets required? You take that. What is artificial magnet?
Magnetism magnet is magnet created by man. Can either be a bar magnet or a U-shaped horseshoe magnet.
So suddenly has improved. His parents must be happy, I guess. Huh? What your mother is saying? Is she still angry with you?
Yes.
So keep improving.
Skill.
At least he's answering. So artificial magnet is man-made. Okay. What is the example of artificial magnet?
Horseshoe magnet.
Temporary
Solenoid. Okay, solenoid.
and permanent.
And it could be temporary as well as permanent. Artificial magnet.
Iron rod.
If it is so what is the example of temporary and what is the example of permanent?
Temporary is permanent is temporary
Solid.
magnet used to lift up heavy weights.
Just the
Solenoid.
not the uses.
Solid.
So solenoid is temporary.
Permanent.
What is permanent?
Permanent is a horseshoe. Magnetic needle.
Yes. Magnetic needle is an example of permanent magnet. Okay?
Magnetic.
How do you make permanent magnet?
By using
By choosing a iron or steel. How do you make temporary magnet?
Iron soft.
By using soft iron. Very important.
Solenoid.
So permanent magnet बनाना है तो जो core है core मतलब जिस पे वायर रैप कर रहे हैं ठीक है that has to be of stainless steel और temporary electromagnet बनाना है so the core has to be soft iron ठीक है good. So I hope you have noted these points. 4, yes, you are done. Show by diagram 3 usual shapes of artificial magnet. This is horseshoe.
Yeah.
This is also horseshoe.
No, this is U-shaped magnet.
U-shaped magnet and
No,
horseshoe is same.
so both, I will consider both as same.
Okay.
Next.
I know.
Magnetic needle is one.
Give it, short one. Let her complete.
How do I draw magnetic needle?
I know. I remember.
Not bad. Good.
So I know proper diagram from the textbook.
Okay, I'll give you a chance.
Magnetic
Okay, you finish. Then we'll improvise. Okay. Nobody will laugh. I mean, it's not comedy circus.
Let's
Okay. And what is it?
This
Huh?
magnetic needle.
It is magnetic.
Okay. So you've got kind of 3 different types of magnets you've got. Okay. But some corrections required here. So this is not looking like a horseshoe. Horseshoe is actually a U-shaped magnet. Okay, it has to be U. Okay. A magnet is not yet a magnet unless you specify the polarity. You have to specify the polarity. Okay. So now this is horseshoe. Second, this is magnetic compass. This is magnetic because it is enclosure. Inside the enclosure, again you have to show the polarity. Wherever you have magnet, you have to show the polarity. Okay. So polarity is actually on the magnet. So this is magnetic compass. What is magnetic needle? Magnetic needle is same thing.
But not enclosed.
It is like pivoted but open.
Stick, there's a stick that's holding it. There's a stick that's holding it.
Like a stick.
That's holding.
Yeah, this is the pivot and this is the magnet.
Even that pivot is a stick. Stick.
So it is straight only, like a pencil tip. Yeah, this is that one. The pivot is sharp and it is resting on tip like this.
So how does it balance itself?
Huh?
How does it balance itself?
Center of mass.
Center of gravity. Not mass. Center of gravity.
So because it is like this,
You
right?
can balance any object when you support it at its center of gravity. Understood?
It's center of mass, right?
For symmetric bodies, center of gravity and center of mass coincide. Both are different concepts. Okay? So when a body is supported, it is at its center of gravity. What is center of gravity? Where the entire weight of the body can be concentrated. What is center of gravity? The entire weight of the body acts at center of gravity. That's how it is balanced. Okay? Okay. Now this is okay. This is correct. Okay? But generally, a magnet is shaded like this. The north one is red, and the south side is blue. Okay? So you just write NNS. Don't put it like this. Okay? So full this part is north, this part is south. Okay? So she has got it right. State. Whose turn now? Okay. Sanskrit.
State 4 properties of a magnet.
One by one. One.
Okay.
Para.
They show us the direction.
It shows the direction when suspended.
When suspended,
It points in
the geographic north.
geographic north.
The north pole of the magnet points at the geographic north pole.
Geographic north pole नहीं जिधर वो point करता वही geographic north.
हाँ तो वही same.
And जो geographic north है, it is actually magnetic south of Earth. Okay, चलो एक property हो गया. What is the property? When suspended, it points towards geographic north. ये हर मैग्नेट का प्रॉपर्टी समझो, ये मैग्नेट है तो इसी प्रिंसिपल पे हमारा मैग्नेटिक नीडल और मैग्नेटिक कंपास काम करता है. ओके, सेकंड प्रॉपर्टी,
The like poles of two magnets will always repel, but the
unlike poles will attract. Okay, so second property. Third property, it will attract magnetic substances like iron. Okay,
Copper.
it will copper nahi.
Cobalt.
So it will attract, magnet will always attract magnetic substances such as iron,
Cobalt.
cobalt, nickel. ठीक है, ये हो गया. और
the magnetic field at a neutral point is zero.
that's not the property of the magnet. That's the situation.
It is the property of the magnet.
What is the property of the magnet? Talk in terms of magnetic field strength.
It's always possible.
It is the most at pole.
Yes, magnetic field strength is maximum near the poles and decreases as you go away from it. ठीक है? So this gives you four properties. So देखो ऐसे questions हैं. So you have to recall it. And this chapter is all about, there are no numericals. There will be situations and conceptual questions. Okay, whose turn? Next.
What do you understand by poles of a magnet?
Yes.
Unlike poles,
Poles of the magnet is, a magnet will have two ends. So the end that points towards geographic north is called north pole, and the end of the magnet that points towards geographic south of earth is called south pole. Okay, so these are poles of the magnet. Okay, then what is the other property of the pole? The magnetic field emerges from the north pole of the magnet, okay, and then enters into the south pole by forming a closed loop. So what is the property? From north pole the field will come out, okay, and it will enter into south pole. So this is how you will show direction. So outside the magnet it is north to south, and inside the magnet it is south to north, like that. Understood? So magnetic field lines direction you have to show like this, and you can have so many. All of them will form a closed loop. So they will also form a closed loop. Understood? So understanding of pole, is it clear? Okay, next. How will you test the polarity of the magnet?
Basic influence of a magnet whose polarity are
That is one way. Bring a magnet with known polarity, right? Then point,
Let's suspend it.
and by suspending also you can figure out. The end which is pointing towards geographic north becomes north pole. That is easiest. Then you don't require other magnet.
suspending it on a putting it on a leaf on a boat of water.
Putting it on a,
Leaf on a boat in a boat of water.
what is he saying?
Putting it on a leaf in a boat of water.
Leaf won't be able to hold it. Leaf will sink itself. Okay? Matlab, why are you going on? Can't you suspend it on land? Just suspend it by tying a thread and hang it somewhere. Of course, you can do it in water if you are for navigation purpose. You want to sail in a particular direction. So if you are sitting in a boat, you can mount it on some pivot or have a thread and hang it like this. Then also it will point in one direction. Okay. Whose turn? There are few things that we should not do. So what is the effective length of the magnet? That is the distance between the two poles. Somewhere given. effective length, so I don't think it is very. That is okay, that's not here, but it is the distance between the two poles. देखो magnet में क्या क्या होता है? Let's say this is north and south. So what is magnetic axis? Poles of the magnet, north and south. North से field will come out, south में it will enter. Outside the magnet, inside the magnet, south to north. That you have seen. So these are poles. Or you can also say end with points, so same thing. Then what is magnetic axis? The line that joins the poles is called magnetic axis. So this is the magnetic axis. Or joins or line passing through the poles. What is the effective length of the magnet? Distance between the two poles. Okay, that is the effective length. Then what do you have? That's it, these two things. Right? In book you may find somewhere the effective length. Let me check this. Okay, so the effective length of the magnet is the distance between its two magnetic poles. Okay, that's what is effective length. Somewhere you'll find it. If not, then you just know this. Okay, next. State one use of magnetic compass. So it's repetitive. We'll skip that. What is one use of magnetic compass?
Find the directions.
Yes.
Sailors sailors use it.
Okay. Sailors use it for what?
Navigation.
What is navigation?
Navigation.
To know the direction in which they are sailing, right? Ultimately, it's the direction. Question 10.
Yes, sir.
ठीक है, 10 is also same. How will it rest? Self-explanatory, quite repetitive. 10th is, what will be answer to the 10th? What will be answer to the 10th?
The north pole of the magnet will be pointing
Yes,
towards
it will be point towards north and rest there. North में जाके रुक जाए. 11. 11 is also the same thing. Okay, now the new question. Question number 12. Whose turn it is? Your turn.
Yeah.
Ian.
Yes, yeah.
Question 12.
Lebanese Ian.
Ian is leading the magnetism chapter. So, what is induced magnetism?
Even the electric current to put around the magnet for a specific level you turn because
Yeah, kind of. But let's say you have a permanent magnet and you have a
iron.
iron bar or iron rod. You are keeping the iron rod near the magnet. What happens? Let's say this is a plain iron rod and this is a magnet. Okay, I keep the iron rod next to the magnet. What will
The
happen?
tip of the iron bar will gain a pole.
Let him try.
The iron bar will act as a magnet.
Keep it simple. When I keep iron bar, it will attract it.
And it will act as a magnet.
So why it is attracted? That's the question.
Due to iron.
Because you know magnetic behavior. It attracts opposite poles. Understood? So if it is north pole, right, in the iron bar, the south pole will be induced temporarily. It will make this also a temporary magnet. Understood? So, the process by which this iron bar becomes a temporary magnet is called magnetic induction or induced magnetism. So the moment you remove this magnet, it again becomes a normal iron rod. It loses its magnetic behavior. Understood? Is that clear? So what is induction? The development of opposite pole. Let's say if this was north, it will develop south. If it was south, it will develop north. In both cases, it is going to attract only, because this is not a magnet. It is an induced magnet. So depending upon which pole of permanent magnet this rod is facing, the opposite pole will be developed here. That is called magnetic induction or induced magnetism. Is that clear? Is that clear? So you have to write all this. Okay. So explain the meaning of the term induced magnetism. I hope it is clear to you. 13 is also repeat. So question 13, the second part, who will answer? I want somebody from the girl side. You take it. Question 13. Huh? Dhruv, question 13. First part I already explained. First part is identical to question 12. 13. Ian, you can also try. Is it making sense here? Ian, Ian, Ian.
CN.
13, second part of the question. Anybody?
The sound, when a magnet is kept near iron rod, the opposite pole is generated on that tip, and then it gets attracted.
So you have to say it in one sentence. Induction precedes attraction. You read that statement? I told you that statement. Induction precedes attraction. Induction कहाँ पे होता है? In the iron rod. Before getting attracted, it becomes a temporary magnet. So induction precedes attraction. Because the moment induction happens, these are opposite poles. An opposite pole will then attract each other. Okay? Simple. So question 13, second part you can write. Induction in the iron rod precedes attraction. 14. 14 is also same. These are all questions on induced magnetism. Okay? So starting from question 12
to 17.
yes, till 17 it is all questions on induced magnetism. So you can mark it with your pencil. Questions on induced magnetism. This is how you should work on your chapter. By making use of volume, so that you have tried all types of questions on all different topics from the chapter. Okay? Now, question number 18. Who will take this? Question number 18. Question number 18. Who would like to answer? Dhruv, question 18.
Magnetic field lines.
What do you understand by the term magnetic field?
It determines the strength of the magnet.
Is the area around the magnet in which the magnetism is the strongest.
Yes. It is the region around the magnet in which the magnetic compass points in the direction other than geographic north. If you remove the magnetic compass will point in north direction. But bring and keep a permanent magnet near it. Then the compass will orient itself in the direction of magnetic field of the magnet. You get it? So how do you describe magnetic field? It is the region around the magnet in which the magnetic compass points in the direction other than geographic north. In short, it is the region around the magnet in which any other magnetic substance experiences magnetic force of attraction, isn't it? If you keep any magnetic substance near the magnet, if there is magnetic field, it will be attracted towards the magnet. So there are various ways of defining magnetic. Is that clear? So magnetic field is the region of influence around the magnet in which the magnetic compass points in the direction other than geographic north, or any other magnetic substance gets attracted towards the magnet. Okay, that's one. So we have discussed all this, right? Next question. State 4 properties of magnetic field line. So first start, what is magnetic field line? Yes. Yeah. What is magnetic field line?
So they are continuous curves
Yes.
in the direction.
So first of all, these are visual representation of the magnetic field. You can't see the magnetic field with your eyes. So on paper, how we represent magnetic field? We represent it. It's a visual representation of magnetic field. How do we represent it? We represent it in the form of closed loops, emerging out of North Pole and entering into South Pole, and inside the magnet from South to North. So it has to be closed loop. Okay, this is how we represent. They are present at every point around the magnet. It's not that if you have drawn two lines and there is a gap between two lines, so it doesn't mean there is no magnetic field. You just have not represented it. Understood? So first property is they form closed and continuous loops, north to south outside the magnet and south to north inside. This is one. What is the other property? They do not intersect each other. Very important. Closed loop, one property. Second, two magnetic field lines do not intersect each other. Why? वहाँ पे दो डायरेक्शन बनेगा, which is not allowed, not possible. So two magnetic field lines cannot intersect each other because at the point of intersection there are two directions possible, which is not allowed. क्योंकि magnetic field एक vector field है, it has magnitude and direction at every point. ठीक है? Third property. What is the direction of the magnetic field at any given point?
North to south.
Inside the
Inside the magnet, south to north.
South, north to south is a general thing. So,
The tangent.
exactly. So it is north to south, yes, but this point and this point, the directions are different. This point it is along the tangent. So it is along the tangent at that point. And what is the direction of the tangent? North to south. Is that clear? So magnetic field direction is along the tangent at that point. The point is on the magnetic field line. तो कर्व पे जो टेंजेंट बनाओगे और नॉर्थ से साउथ डायरेक्शन में जाओगे, वो तुम्हारा मैग्नेटिक फील्ड का डायरेक्शन हुआ उस पॉइंट पे. अब देखो यहाँ पे क्या डायरेक्शन हुआ, तो ये डायरेक्शन मान लो ये पॉइंट ए है, ये पॉइंट बी है, दोनों का डायरेक्शन सेम है क्या? डायरेक्शन सेम है, सेंस सेम है, नॉर्थ टू साउथ सेंस में, लेकिन डायरेक्शन अलग हो गया. इसका डायरेक्शन इधर है, मान लो नॉर्थ साउथ ईस्ट वेस्ट है, ये क्या हो गया? नॉर्थ ईस्ट डायरेक्शन, और ये क्या है? साउथ ईस्ट. डायरेक्शन अलग है, समझ आया? तो डायरेक्शन कौन देता है? टेंजेंट एट द पॉइंट. इन व्हाट सेंस? इन गोइंग फ्रॉम नॉर्थ टू साउथ. नॉर्थ टू साउथ जाते टाइम उनको डायरेक्शन का सेंस मिलता है. और यहाँ पे क्या हो गया डायरेक्शन? क्या है? साउथ वेस्ट है. बात समझ में आई? तो डायरेक्शन इज डिफरेंट एट डिफरेंट पॉइंट्स, बट उस पॉइंट पे टेंजेंट बनाने से डायरेक्शन मिल जाएगा व्हेन यू आर ट्रैवलिंग फ्रॉम north pole of the magnet towards south pole. Okay. So did we cover all the 4 properties? ये 3 हुआ है. कितना हुआ? मैग्नेटिक फील्ड लाइन का 4 प्रॉपर्टी हो गया. कौन सा?
Closed and continuous curves. They don't resist each other.
Yes.
Not the south.
Third direction.
Direction is determined by the tangent.
This is the third one.
Yeah.
Okay. Fourth. Wherever the field lines are crowded, the magnetic field strength is more. Wherever the magnetic field lines are less crowded, the magnetic field strength is less. So where it is less crowded, in this region, and near pole it is crowded maximum. So the magnetic field strength is maximum near the poles. And as you go away, the magnetic field lines spread out. So wherever the magnetic field lines spread out, the field strength is less. So how will you check? How will you check the field strength? One way is to place the compass. If it shows more direction, more deflection, then the field strength is more. What conference is going on, Dhruv? What are you discussing?
He's saying at the North Pole and the South Pole are the iron deposits to make the geographical models.
Iron deposits. It is inside the earth.
And in the pole. Pole.
No. Inside the earth, center, passing through the center of the earth. You can imagine earth to be a giant magnet.
Pole.
Core.
Vikiran iron. Leafy.
Whatever.
It's nice.
Whatever. Just check on the Google what it is. Okay. And the clarity on this subject is still evolving. It is not yet fully understood. It's called geomagnetism. Okay. What's the matter? शांत हो जा. So any more questions about properties of magnetic field lines?
Yes.
Are we sorted with question 19? Okay, let's go ahead. Question 20. Read question 20. This is an experimental question. What happens in question 20?
Because of the magnetic field,
Yes. So what is happening to the iron powder?
They arrange themselves along the lines of
Why?
Because of the magnetic field line. They have maximum field line.
because the magnetic field lines have the maximum strength.
So what is happening to the iron particle, the powder?
They are arranging themselves.
Exactly. They are getting attracted.
Each particle acts like a tiny magnetic compass. The magnetic induction takes place, and therefore it arranges itself along the tangent.
Okay.
You get it? The iron powder का जो particle है, each particle acts like a magnet, and magnet has a property to orient along the magnetic field line, stronger magnetic field line. So that's why when you gently tap, all of them arrange along the magnetic field lines. Is that clear? Yes. Answer question number
22.
20. Answer 20. I was just explaining that time you were discussing. 20 we just discussed. What did we discuss? You answer? Ritvik?
Me?
Satvik?
Liquid.
हाँ तेरे को तो खुद ही पता नहीं तू क्या है.
Yes, sir. Yes, sir. 20. Wondering.
21. That's right.
Iron fighting acts as a small magnetic compass and
Because it gets induced.
Induced magnetism word use करना है. Temporary है. Magnetic compass नहीं. Magnetic compass is a permanent magnet. Each iron filing particle, okay, induces temporary magnetism and therefore orients itself along the magnetic field line of the permanent magnet.
So what is the chemical composition of a magnet?
It's a iron,
Iron.
soft iron. That's it. Soft iron, stainless steel.
But what about iron filings?
Is a iron, Fe.
Then why? So then now we go to magnets.
That's not in the scope to your level. Okay. Right now you understand basics of magnetism. You're just doing level. First you understand what questions are asked. Are you able to answer it correctly? So limit yourself till here. In 9, this much you know is sufficient. Okay. Next. 21. I can see what you're doing. You feel you're fooling, but you are the biggest fools actually. Everything is visible what you're doing. Okay, so focus here. What is it? Explain the method of plotting the magnetic field line.
We keep we take a bar magnet and keep a magnetic field.
We first draw the outline of the bar magnet.
Okay, and then
Then we start keeping
we keep the magnetic compass.
At the North Pole. Then
First we mark one dot and then keep the magnetic compass over there. So dot is aligned with the south pole of the magnetic compass. Wherever the north pole is pointing, you mark another dot. Then shift the compass to the dot mark and repeat it.
The south pole, right?
Yes. अभी तो north पे नया dot बनाना है. Mark dot पे south रखना है, ठीक है? And then when you connect the dots, okay? So this process you repeat till you reach the south pole, and then connect the dots. Then you will get one magnetic field line. So you can draw it on both sides along the length of the magnet. You can repeat this process on both sides of the magnet. Okay? By placing the starting dot could be different. Choose starting dot different at different points. So कैसे start कर सकते हो? Let's say you have placed the magnet like this. So you can choose one dot here. Then keep marking the dots of the north pole. Then you join it.
magnetic field lines.
Okay, this is how you draw.
Sir, magnetic
Then next dot you can take here. So you can draw it. How to plot magnetic field line? Did I show you the video?
Yes, sir.
So you have already seen. So this is how you can plot it. Okay. Okay. 21 हो गया. 22. I want somebody from girl side. You take it. 22. Who would like to answer? 22.
A point in the on the magnetic field of a magnet.
Wait. The question is to the girls. Yeah.
A point where the magnetic field of the magnet and magnetic field of the
Cancel each other.
opposite and magnetic.
Yes. So, in short, at neutral point, net magnetic field is zero. पहले तो वो बोलो.
Resultant magnetic force is zero.
Net force नहीं, field. ठीक है? Field की वजह से force exist करता है. जब field ही नहीं तो force तो anyway zero है. Okay. So at neutral point, magnet's magnetic field line cancels the Earth's magnetic field. Okay? Because they are both equal and opposite. 23 भी वही है. How is the position of neutral point located with the use of a compass needle? 23rd question. What is the neutral point? Point where the net magnetic field is zero. और जहाँ पे magnetic field zero है, वहाँ पे magnetic compass का
Random direction.
ठीक है? So how will you identify? Because at neutral point, the magnetic compass will show random direction. Okay? So here. Or it may rotate fully. ठीक है? It may rotate fully also. And may settle down anywhere.
Sir, वो घूमता रहेगा।
कुछ है ही नहीं डायरेक्शन, या ऐसे जा रहा है ऐसे हो रहा है, या फिर मान लो तुमने मैग्नेटिक कंपास एक नॉर्थ डायरेक्शन में ले गया है वहां पे रख दिया, तो जरूरी नहीं है कि वो नॉर्थ में पॉइंट करे, वो कहीं हिल सकता है इधर। ठीक है, ओके। 24, what is the electromagnet?
Temporary magnet.
Example,
Solenoid.
with
Battery.
soft iron.
Oh, sorry.
Okay, solenoid in which current is flowing and soft iron is its core. Understood? That makes a electromagnet. So what is an electromagnet? First thing, all keywords. What keyword should come in the answer? It is temporary magnet. And example में solenoid, current carrying solenoid with soft iron as core. ठीक है? Name the material used for preparing an electromagnet. Soft iron, soft iron. वही है, electromagnet soft iron से ही बनेगा. तभी तो temporary होगा, क्योंकि जैसे ही करंट ऑफ करोगे उसका मैग्नेटिक बिहेवियर विल स्टॉप सडनली। ओके, लेकिन अगर सॉफ्ट आयरन की बजाय अगर तुमने स्टेनलेस स्टील यूज किया हो तो करंट बंद करने के बाद भी इट विल रिटेन मैग्नेटिक बिहेवियर, बिकॉज स्टेनलेस स्टील में क्या हो जाता है, इट हैज अ गुड मैग्नेटिक रिटेंशन एबिलिटी, बट द रिटेंशन एबिलिटी ऑफ सॉफ्ट आयरन इज नील। ठीक है, सो दैट्स व्हाट इट इज। Question 26. First part we have already answered. How electromagnet is made. What are the
number of rotations?
turn?
The rotations, right?
Turn, rotation.
Yeah, turns and the number of cell.
The number
Power. The number of
by
cell.
increasing the magnitude of current. You mean.
Yeah, cell only, right?
You have to say by increasing the magnitude of current.
By adding many cells.
वो बोलने की जरूरत नहीं है, वो अंडरस्टूड है। If you increase the magnitude of current मतलब क्या किया, या तो रेजिस्टेंस को रिड्यूस किया अगर रियोस्टेट है, या फिर नंबर ऑफ सेल्स इंक्रीज किया। Okay, there are two ways by which you can increase the current.
Increasing the number of
By decreasing the resistance in the rheostat or by increasing the magnitude of current by increasing the number of cells in the battery. दो तरह से कर सकते हैं।
So, can we use a dead magnet as a solenoid?
Can we use a
dead magnet?
dead magnet? What do you mean dead magnet?
Like the magnet without its power. हाँ.
मतलब
नहीं, it was permanent magnet पहले। पहले permanent magnet था।
फिर अब उसका magnet
तो अगर permanent magnet था तो वो तो फिर soft iron है ही नहीं। इलेक्ट्रोमैग्नेट का मेन कंडीशन क्या है? सॉफ्ट आयरन। तो डेड मैग्नेट था तो मतलब उससे पहले परमानेंट था कि नहीं? मतलब वो सॉफ्ट आयरन नहीं था। That answers. Okay, next. Question 27. I want somebody to come on board and draw it. Question 27. Come fast. Okay, you can come in group also if you want to try it together, but not more than two.
Lebanese Ian.
So she is doing question number first, right? What question you are attempting? This is question number 27. So this is a fun chapter actually. Non-numericals only concept and not very hard. Okay. So she is really like, देखो उसमें क्या करना चाहिए था? मैं एक चीज बताऊँ।
हाँ वो ऐसे ऐसे करके बीच का इरेज कर देते
नहीं नहीं, मैं वो बोल रहा हूँ rather than देखो जैसे तुमने यहाँ से यहाँ किया ठीक है, you can keep some gap, मतलब ये जरूरी नहीं कि इसको उस पे टच करो ठीक है,
ओके हाँ
you can keep some gap because the wire is also going from behind. Yeah. So this you are taking like this, but you show the direction. Yes.
ये कहाँ से आएगा
ये एक मिनट ऐसे नहीं ऐसे 10 मिनट वेट ये जो तुमने किया है ये पत्ती so everybody you will require little practice to draw these diagrams. अब ये ऊपर से आ रहा है ना सीधा नहीं होगा ठीक है, तो स्पेस दोगे तो तुम्हें क्लैरिटी मिलेगी. It's not a free time for you all. Everybody draw the diagram in your notebook. I'll come and check. So whenever we are attempting questions, somebody trying on board means you have to try in your notebook. It's not free time for you.
No.
Draw it on your body. हाथ पे चलो.
सर करेक्ट
Why is my pen?
So why did you put a resistance here? Is it a resistance or rheostat? Rheostat. Open and then like this.
कैसे
You will connect. Yes.
ओके ऐसे
So this becomes rheostat. So what was the question? You are required to make an electromagnet from a soft iron bar. So what is soft iron bar here? This is soft iron bar. Switch, okay, cell, rheostat, then current. Direction of current is like this, everywhere. So ठीक है. What about polarity? Which polarity will develop? So you see from this side it is clockwise.
the clockwise है
So what it will be?
south pole
This side will be north. ठीक है. So have you answered all everything? ठीक है. So I think she has got it right. ठीक है. No need to draw the coils very close. मतलब you can draw it like this also. Less number of turns is also. Okay, I'll see you after the break.
sir
I'll check everybody's after I come back. In the meantime, you can improvise.
No, bro. Oh, okay, it's okay, it's okay. It's better than the last one. No. Careful. You will okay. It is a
Chesky.
do it there. Bro, no. Why you
Check.
You're dead. Oh, crazy.